So this is what we were doing in the previous lecture. I showed the uniqueness of local solution, or in a small interval around the point t naught, you have, right? So you have a solution. So what we said is the solution exists in the interval. Let me see what is that. Yeah. So xk is defined in mod t minus t naught less than or equals to h. So sorry that I have to go somewhere to meet someone urgently. Okay, we'll just say what we did in the previous class and what is that we are going to do in the next class maybe. So we showed the previous class that there is an interval around this, which we call it as t minus h to t plus h, t naught minus h to t naught plus h, where you have the existence of a solution. Okay. So the next session, what the aim is to see how large this h can be. Okay, that is, can we have solutions for all t? Okay. So under what conditions we have hypothesis solution exists for all t. And for all t means in the whole of real line. And if not in all t, not in the whole R, then what is the maximal interval? What could we say about maximal interval? So this is what could we say about the maximal interval? Okay, so one thing what we can see is the h is given to be the minimum of a comma p by m. So if a is the you see that mod t minus t naught is less than or equals to a. This is what we have. Mod x minus x naught is less than or equals to b. So if f is defined, say, on an interval, okay, this is the time variable to r. Okay, so if this is Lipschitz in the whole of this domain, okay, Lipschitz in whole R, then I can take this b to be arbitrary. Then b can be arbitrary. Okay, so when b becomes arbitrary, so I can take this b to be anything. So b tends to infinity. So if b tends to infinity, this minimum becomes actually a. So that means the whole interval. So this is the whole interval where we are considering the problem. So this is again when if f is a global Lipschitz condition, global Lipschitz continuous function, then this a can be, this a is the minimum, the interval is the whole interval. That is where you are taking. So maybe if the function is defined in the whole of real line, f, then the solution exists in the whole of real line. So this is one thing which we get from the Wittkahr's theorem. Okay, so I will also tell you the other things about the other two questions. So I'm sorry that I have to go somewhere urgently. So I will stop it here.
सर वापस